Hi everyone, so we have already started a lecture series for Laplace transformation. So in this lecture we will discuss about first shifting theorem of a Laplace transformation. So what is the first shifting theorem? So for that purpose we are going to discuss two methods. First method is if Laplace transformation of f of t is equal to phi of s, then we only have to prove that is Laplace transformation of e raised to at into f of t is equal to phi of s minus a. To prove this Laplace transformation, that is to prove this value, we will use concept of, that is a definition of a Laplace transformation, which we have already discussed in lecture number 1. So that definition is, by definition of a Laplace transformation, so that definition is Laplace transformation of f of t can also be written as integration from 0 to infinity, that is t has a range from 0 to infinity. First term is always fixed, that is e raised to minus st, into this second term, that is f of t into this dt. So this is your definition of a Laplace transformation. So with the help of this definition, we are going to find the value of this Laplace transformation. When we replace this f of t by this value, then what we will get, that is Laplace transformation of, now f of t can be replaced by that term, that is e raised to at into this f of t is equal to, so same as this integration, that is integration will remain as it is, that is integration from 0 to infinity. First term will remain same, that is e raised to minus st. Now this here we have f of t, therefore we can write here f of t. Now in place of f of t we can write this term, that is e raised to at into this second term is f of t, that is f of t. So f of t is now replaced by this term, and this last one is, that is a dt, that is we can write this dt as it is. Now to solve this equation, that is integration from 0 to infinity, compare this first term and the second term, both have a same, that is exponential part, therefore common term, that is exponential part. Then we will get this as a e raised to minus s minus a into t, the second term as a f of t into this dt. Okay. Now consider our given condition, that is this L of ft is equal to how much, phi of s, but in answer we have already discussed about this L of ft, because L of ft is nothing but this integration, and this integration is equal to how much, this phi of s, that is s is here, therefore e raised to minus st, that is s is here, this is a plus, this is a minus. Okay, so this is the integration, and now we have obtained this integration. Then with the help of this condition and this condition, we can write this integration as, that is convert this into phi. So phi as it is, here we have a minus sign, then write it as a plus, and this s minus a constant term, therefore write as a s minus a. So this is your answer. This is a possible just because of this condition, because we have L of ft equal to phi of s, but L of ft is equal to this term. Now only compare this term and this term. This is a possible is equal to phi of s, because this is a e raised to something into f of t dt. Similarly, we have obtained this value e raised to something into f of t dt, and its value is phi of s, and this is possible because e raised to something, that is minus s is its a coefficient. Here we have a minus sign, but when we write its a value, that is we have to consider it's a plus sign, that is its opposite sign. So compare this with our given integration, that is this is a s minus a, so we can write this as a s minus a, and a negative sign is converted into positive sign. So we have obtained this value, that is Laplace transformation of e raised to at into f of t is equal to this phi of s minus a. So this is the first method of first shifting theorem. Now main question is how to remember this property. So when we have an example like this form, that is Laplace transformation of e raised to something into something function, then its value will always be, that is a phi and s is always fixed here, but this plus a and this minus a, it is a totally depends on this function, that is e raised to something. Here a contains positive sign, therefore consider its opposite sign, that is a minus sign, and this coefficient a, take it as a like a. So when we have a e raised to at, that is plus at, then write it as a minus a only, and this is nothing but our formula.